Now we will discuss test based on F distribution, and we know what is actually meant by F test. So F test is a ratio of two chi-square variate divided by their degrees of freedom. So that is nothing but my F test. So to test which is based on F distribution, we have few assumptions. So the assumptions are the samples are simple random samples. The second assumption which is important for testing F test is the samples are independent of each other. The parent population from which the sample are drawn are taken to be normal, and this test is related with testing the equality of two population variances. So that is my null hypothesis in this case is sigma 1 square equal to sigma 2 square. So there are two samples and we need to test the equality of these samples. So I mean equality of these two population variances. So suppose x1, x2 up to xn1 be a random sample of size n1 from normal population with mean mu1 and variance sigma 1 square. So this is my sample number 1. So which I have denoted by x. There is one more sample y1, y2 up to yn2. So these are the observations of a random sample of size n2 from the normal population with mean mu2 and variance sigma 2 square. So as you are aware that the testing procedure follows 4 steps. Step number 1 is hypothesis. So we have to set up the hypothesis. Step number 2, which is related with the test statistic. Next, the step number 3 is related with the critical region, and step number 4 is the final conclusion about this testing procedure. So therefore we need to first set up our null hypothesis. And what is our null hypothesis in this case? The null hypothesis is, so H naught is sigma 1 square equal to sigma 2 square. So we are assuming that the two population variances are same. So as we know that the sample mean square is an unbiased estimate of population variances. So therefore we first find the mean square for the first sample. And what is mean square for the first sample? So that is denoted by S1 square. And what is S1 square? So S1 square is nothing but summation x1 minus x bar. So xi minus x bar square divided by n1 minus 1. And if you simplify this, so we will be getting that summation xi square minus n1 x bar square divided by n1 minus 1. So likewise, there is one more sample, and the sample mean square for this sample is S2 square. So S2 square is the sample mean square of second sample, and that is summation yi minus y bar square divided by n1 minus 1. And if you simplify this, we will be getting summation yi square minus n2 y bar square divided by n2 minus 1. And we know that from sampling distribution, so suppose if I take one more variable as u, and u is what? So n1 minus 1 s1 square divided by sigma 1 square, and this follows a chi-square variate with n1 minus 1 degrees of freedom. So we know that suppose if earlier we have seen a chi-square variate in which we have defined that the variable u can be taken as n minus 1 s square divided by sigma square. Since there are two samples in this test, we are taking this value as one as u and the another as v. U represents for the first sample, v represents for the second sample. And what is my u? U is n1 minus 1 s1 square divided by sigma 1 square. So that follows chi-square with n1 minus 1 degrees of freedom. And there is one more sample which I am representing by y, Now the variable I am taking this as V, and what is this V? V is n2 minus 1 s2 square divided by sigma 2 square, and this follows chi-square variate with n2 minus 1 degrees of freedom. Since the samples are independent, therefore the representation of these samples U and V are also independent. Now what is my F test? So as I have stated earlier, F is nothing but the ratio of two independent chi-square variates divided by their degrees of freedom. See, U is one chi-square variate, V is another one chi-square variate, so that is divided by n1 minus 1, that is my degrees of freedom, and V should be divided by n2 minus 1, that is the another degrees of freedom. So U should be divided by n1 minus 1, V is divided by n2 minus 1, and we are taking this as a ratio. So F test is the ratio of two independent chi-square variates divided by their degrees of freedom. So if you simplify this, we will be getting this value. So U divided by n1 minus 1. See, this is my variable U. So what is U? U is nothing but n1 minus 1 s1 square divided by sigma 1 square. Suppose if I divide U by n1 minus 1, so that is my s1 square divided by sigma 1 square. So that is I have written in this equation. And the second one is what? S2 square divided by sigma 2 square. And it follows a F distribution with n1 minus 1, n2 minus 1, comma alpha. So alpha is my level of significance. Since the values of F distribution given in statistical table are constructed for F ratio which is greater than or equal to 1, larger out of s1 square, s2 square is taken in the numerator of the test statistic. So thus, if s1 square is greater than s2 square, then the value of s1 square should be taken in the numerator and s2 square should be taken in the denominator. And under my null hypothesis, so as sigma 1 square equal to sigma 2 square, the test statistic becomes F is equal to s1 square divided by s2 square, that follows F distribution with n1 minus 1, n2 minus 1, comma alpha. Alpha is my level of significance. Suppose if the case is s2 square is greater than s1 square, so in that case what we have to do is s2 square should be taken in the numerator and s1 square is taken in the denominator. And under the null hypothesis, sigma 1 square equal to sigma 2 square. So this is my null hypothesis. So the value of F becomes s2 square divided by s1 square, and which follows F distribution. We have to reverse the degrees of freedom. First we have to take n2 minus 1 and it should be multiplied by n2 minus 1, comma n1 minus 1, comma alpha. Alpha is my level of significance. And what is the critical region? The critical region is if probability of F greater than or equal to F n2 minus 1, n1 minus 1, alpha equal to alpha. And if this holds true, that means if the calculated F is greater than table F, then we have to reject the null hypothesis, otherwise we have to accept it. So the acceptance and the rejection of the test depends upon the critical region. If the value of calculated F, so what is the calculated F means? The value which we have calculated by using this test statistic. If F is, the calculated value of F is more than table F, then we need to reject the null hypothesis, otherwise we have to accept the null hypothesis. So this is all about the test based on F distribution, in which we are testing the equality of population variances. There is one test in chi-square test in which we are interested in testing H naught sigma square equal to sigma naught square. So that is one sample test. So one sample chi-square distribution for one sample variance test. But this is the equality of two population variances in which we are using F test. So this is all about the testing of hypothesis. Today we will stop here and continue with the next session. Till then, goodbye.